collide and new worlds be. Veritas Automata, the truth in machine, shaping reality in every routine.
Hello and welcome to the Veritas Automata Deep Dive. I'm Ben Savage, the CEO and founder of Veritas Automata, and with me I have Dr. Sarkar. Today he's going to see some demos that he wasn't prepped for. We prepped for some papers, but I didn't want that. I had some free time over the weekend. And please like, subscribe, follow us, ask us questions, participate in the comments. We want to hear your feedback on what can make this interesting. So this spring, you might play a lot with the video models because of our friends over at Blue Loop and Savage Content. They're always looking at how can they be creative.
Right.
So I took a couple of different things that I'd been working on to show them some examples of how you can use some new technology. So in the last week, Kling AI dropped the new video to video transfer system. So I can use that video to go drive something. So I can image in one style and a video in a different style and drive it. And then LTX, which is another tool we've been looking at. At LTX, I think we'll have to come back to. They've got some new open source models you can run local.
Okay.
But in the cloud, they've got some that are audio to video, which is interesting because most of the tools you find, you either take an image and you let that drive it by prompt, or you then use another video to go drive it. And then there's some of the lip syncing and stuff. And I'll talk about some things I've learned just in the 24 hours since that model's been out. So the first I'm going to add is this is one where I used a Nano Banana to create the image. So Nano Banana is one of Google's image models. So I used that to create a style, and then I drove it with some video from our friends at Blue Loop or Savage Content. So this is the first
only cat who knows how to swing.
This is impressive. Yeah, this is just a quick video, and I'll play that again.
So the cat's the only
cat
the
motion transfer
who knows how to swing.
And that one worked really well.
Yeah.
Then for the LTX one that I talked about, that one, I just took a clip of the audio from the same performance and didn't do any other prompting. And this is using a stock image. So LTX, when they have this set up, they've got like 3 little demos. I just used one of their demo images and the audio. And this.
Still a cat's the only cat who knows how to swing, who wants to dig a long hair gig or
it works impressively well for what it does. And then I was trying to on some of our content. We've got a couple images that Liz, our graphic designers, created that I really like that when we use presentations. And then we've got the theme songs. I figured now, okay, if this is going this well, maybe I should see what happens for using it for a theme song. And the first time I did this, I didn't have good results, and I'll explain it.
Veritas Automata deep dive below, where seconds harm the human.
So like it got the background, it got some of the other stuff really cool, but it wasn't doing the lip syncing.
Right.
And I'd already upscaled this image from what I'd originally had because I'd done some bad things and didn't get the original from Liz. And what she had done, I just did a screenshot from a presentation. And I realized the issue was the lips aren't clearly defined. You see there's a lot of black around.
Right.
So I went through and used an AI tool to clean up the images because I am not skilled enough to do it in Photoshop. And I got better results. So a lot of what it shows is when you're working with these tools, you do have to do a little bit of scientific theory, right? You're going to go try something, see what happens, come up with a thesis on why it was wrong. And watch that first one. Why isn't this working? And I realized it probably couldn't identify the key features it needed to go make it move.
Right.
So the next thing I'm going to work on is my prompting technique. These were all one shots. So these were not highly detailed prompts I created with them. So I thought that was interesting as we work through it.
Right.
Then again, back to I've been experimenting.
These are pretty good, right? So for content generation and stuff like that, I think this is going to be pretty impressive. Is if you look at the current trend with the new youngster, right? They are watching very short clips. And this could customize and tailor that towards their taste, basically, right?
And I think there's a lot of possibilities to use these for storytelling. And I want to be clear, these don't replace artists. I think it's very clear you need to work with artists, particularly to generate some of the original content. But it does give you ways, if you are not an artist, to go tell those stories differently than you might. I think if you're trying to do something really creative or unique, not having some of that artistic skill, you're going to have to find those people to work with it.
Right.
Because the models can only do things they've seen before.
Correct. And often you mentioned that a lot of them needed seed images or the music, right?
Yeah.
That's probably it's kind of the creativity is getting distilled to the real creative pieces of it, and the boring part is probably getting done by AI. Kind of similar to what's happening in the coding world, right?
Yeah, I think so, but I think you're going to have to be cautious with the art side, because I think there are things that humans can do that a computer still can't. The way they can make random associations and do some of that, and then everything I've seen, people are just much better at figuring out like word patterns and wordplay and rhymes and things like that, which is really important to making a good song or a good hook. And it's the same thing for art, right? There's lots of little subtleties that a human does that I don't think a computer will ever do. It doesn't mean you won't see a lot of AI generated things, or maybe you work with an artist to go generate a character and you have them help build some of that background for that character, and then you use AI to do the animation. Because animation does involve a lot of boring steps if you've ever been through that process. You've got to go do all the keyframes, and then someone has to go animate all those frames in between. So if you can use an artist to go generate just the keyframes and save some of that so you don't have as much, I think there's some possibilities there. But I think you always have to balance if you're trying to create true art. Now, there's a difference between some of what we do commercially to go create an ad or create a video or create other things. Where to say those are not as much art as some other things. But I think we always have to balance that in how we use the tools. And just realize there are limits. Speaking of limits, I've been working on AI to do some storytelling, and I was using this as an example of how do I test a new coding model, because we're talking about coding models. And so Google has anti-gravity, which is their AI coding tool, which can do everything from vibe coding to conventional coding. And so I created a set of requirements at anti-gravity, and I was really excited. So let me share my screen real quick. And that is not what I want. Why is it not showing me the window I want to show? Just a second. I have broken something. This is what happens when you turn me loose on my own. Does this show the window? Okay, now I can go find it. So I was super excited because I came up with the requirements, and it created this really, really cool UI, which I thought I was going to get. And so this particular tool is designed to take a crew AI set of agents in a hierarchical architecture, which we'll come back and talk about AI architectures in a minute, what that really means. But it was where each agent basically is going to tell or help you build parts of the story, and use this as a nice interface to go do it, because I'm lazy and I don't want to have to go code each agent. So that's what it showed me what I was going to do. And so I built it. And then it may have forgotten some details. As you can see, I'm missing most of the really cool interface. Now, what I would say is it kind of works. And let me go back to StreamYard, and I'll show you how I know it kind of works. But as with many of my AI experiments, what we realize is that there's a lot of work to go do. We'll do that. You're going to get some, go to the background there real quick. But what you can see is here is it's running the agents kind of, but it's got some issues in how it's bringing it into the database, into the memory, and some of the other things. So I've got to work through and debug all that. But it's interesting because it's like a 3/4 working application, which is the reality is where most of mine get without a lot of manual intervention from me. If you just try and vibe code it.
And you mentioned this was all local too. So
yes. Yeah, I should mention that I do end up trying to do most of this on hard mode, in that I try not to use the cloud APIs as I do these experiments. Because when I'm thinking about these, it's for storytelling, or how would I apply this for a customer, it's a lot of times people want to protect their data. And so if I know I can make it work on hard mode on the local, whether it's Olama or BLM or one of those different tools, I know that it will also work in the cloud. Otherwise, I don't necessarily, if it works in the cloud, they've got so many tools and so many things that actually do make it easier. You can't guarantee it's going to work local. And if you really want to protect your data, knowing it's running on your box is the only way to go do that.
Yeah. I think with the local, the reason it breaks is not the capability of LLM, is the output formatting. It doesn't follow the strict instruction you gave, that is some of the crew AI and stuff in order to work has to be in a certain format. You got to invoke the next agent, and it has to be in certain ways so that the routing happens right? And if they misplace a semicolon or a colon or something, then it starts to break down very, very quickly.
Yeah, well, and that's, so let's come back to that in a second. Let's talk about general, because there's a whole bunch of different flavors of AI work out there, right? And what I mentioned is I was using a hierarchical framework in this. So what that means is I've got an orchestrator agent that runs over the top and a bunch of other agents that are running tasks and responding back.
Yeah.
The other way to do it is more sequential, and different frameworks work differently for that, right? Because I was looking at Langflow in this case and Crew AI. Crew AI is, Langflow claims you can do hierarchical. I haven't actually made it work yet. Crew AI is known for that. I think AutoGen fits in that. Some of the Microsoft frameworks fit in that kind of scenario where they're good for that. And that's important depending on the kind of problem you're trying to solve.
Yeah.
But I think you're right on the data export piece or the data output, that structured JSON. Was actually having a conversation with someone yesterday where they're talking about how important to reducing hallucination for them using the JSON line format was, the JSON hell. And you can configure some of these tools to do that, but I think you're gonna get much more consistent results out of those cloud APIs.
Correct. And some of these open source model on Ollama, they have a tag tool use. They will be a little bit better because they've been trained on calling those tools. To call and invoke a tool, you have to produce output in a certain way, or that tool doesn't call because it's not a LLM calling; it's a system layer looking at the output and triggering certain tools and feeding the input in, right? On the hierarchical side of the agents, there's another one, kind of a nuanced, is a committee-like thing where they don't have an orchestrator; they are just round robining and having a discussion among each other. It's an interesting setup. It may not solve bigger business problem, but if you have an open proc question, that's where you will see a lot of benefit of this crosstalk between different points of view.
So what framework do you like to go do to build those?
So I'm a little bit weird because I build my own frameworks. I need that granularity and the visibility and traceability on a lot of the things. I do have used Crew AI and LangChain in the past, but when you want to do something new and different, often you drop in and do your own tooling. A lot of those tools which is out there really helps to accelerate the speed of development, but when you're going in the edge and trying to do something,
well, I think it's both the edge or when you really want to harden it for production, right? Because the challenge is you don't control those frameworks.
Yes.
So if they push an update or you end up with an update, it can break how things work.
Correct. And that's the brittleness of LLM, is that what in the old world we used to call the model drift in traditional model, right? With LLM, they also have an update and your prompts don't work as well, right? So those issues still remain as of today. So
so we'll see on my continued vibe coding experiments. And right now I'm actually working on a different approach because I want to go test, because I got access to IBM Bob. That is their cunningly named new AI development tool. So I want to run basically the same set of requirements through Bob, Anti-Gravity, Kiro, Cursor, Claude Code, and see what results I get. Because so far what I've seen is the different tools will take vastly different approaches to very similar requirements in how complex an app they go build, for better or for worse.
Yeah, I think I have access to Codex as well as the Claude. They take completely different approaches for the same requirements. I've seen that happen. But not so much on the local side. I haven't tried those out yet, but you are going the hard route and trying it local, which makes sense.
Well, when I'm using those coding tools, I'm actually using their cloud services to go build it. But I'm still trying to get something that's going to run on my local machine.
Okay. So you're using local Ollamas to do the inference, but not during the design and build side.
And that's mostly because I've been too lazy to go set up a truly local coding agent with like QuenCode or one of those. Nemotron, GPT OSS are all actually pretty good. I'm still fascinated by using the same model. You can be using GPT OSS, for example. You can put the same prompt in, and it will give you two radically different styles for solving the same problem with the same programming language. It's like you've got 3 different programmers that chooses one. It's very weird.
And these are quantized model too, right? Most likely.
I'd have to check. I think generally they are, because I'm pulling them through Ollama. And that's a good point, right? That's one of the papers we were reading this week, which was talking about the impact of quantization on models. So, one of the things that people don't talk about when you're running these tools locally is A normal model is at what, FP16?
Yeah.
Is full quantization, and then a lot of people are running them at FP8 or FP4.
Yeah.
And what that means is you're losing data either because you've distilled it and you've removed rows out, or you've actually reduced the precision of the math that it's using to go do this.
Right, right. And one of the interesting thing in that paper, and we'll probably link it in the video, is that during coding, right, it uses similar tokenization as human words, but coding has a lot of artifacting around spaces, semicolons, brackets, and stuff. And if you look at a code, most of the code is just those special character and spaces, right? What the researchers found is that when they distill it, those artifacts become more and more prominent. So you're, the code doesn't work because they're dropping in extra bracket here, extra space here, especially languages like Python, which can be sensitive on how you indent your
Python
code.
be sensitive on indentation. The number of times I've spent hours troubleshooting, oh, it's this space. It's like, give me brackets. I learned C++ early on, so I'm biased.
So, those kind of tend to hamper it quite a bit, versus quantization actually elevated it. It made it even better, which was weird.
But it depended on the language, right? That some languages like C++ or something where it doesn't really follow the English lexicon, weren't as impacted.
Yes.
But Python, which does use a lot of the English lexicon, and you've got the eternal debate of Python developers, is it tabs or spaces? That is massively impacted by the quantization or distillation.
Yeah, because it's weird because we don't have a different tokenization system for coding versus the English language. Yeah, I agree. There's a lot of code out there, but against that kind of, so it kind of boils down to when you are doing a lot of this work, it's about shaping the probability distribution. If you look it down underneath, it's not. At that point, it's not about the context. That's kind of an input side of things, but how you're shaping that, right? If you have too much noise when you are doing some of these methods, right? There are other papers we're going to discuss today as well. How you're going to push the model towards certain output is pretty much your shaping the probability distribution, because it's any LLM would be sampling from a distribution. And if you have a control on the shape of the distribution, you can tend to make it better, right? So,
well, and I think a lot of it, again, this just goes back to it's choosing the right tool for the application.
Right.
So it's spending the time either to go test a bunch of models for your use case or to do the research and look at what other people's tests have done to say which model is going to be.
Right.
And again, this is where I think I'm probably unusual in that there's not one model I use consistently. I use OpenAI a little bit. I use Claude a little bit. I use all the local models a lot. Like I really like GPTOSS for some things. I like Nemotron for some things. Nemotron for a 30B model is amazingly fast if you haven't used it. I've started playing with some of the liquid models. I was playing with, they just had a new LFM 2.5 thinking that came out, which is a 1.2 billion parameter model. But so far, it's giving pretty good answers on a couple things I've tried. It's not available via OLAM. I've got to use LLM Studio or BLM or one of the other tools to go run it. But the speed at which it generates stuff is impressive. So again, when you think about this, you got to get a feel. I'll use the term, you got to get a vibe or a feel for what these models are going to go give you responses at, and then think about the use case. So I bounce models a lot. I start in one and I bounce between 2 or 3 others if I'm doing something sometimes.
I mean, that's a good way to kind of, test out different approaches and see which fits, kind of a thing. What was the other paper we were going to talk about?
Well, we were talking about quantization, and you were talking about how that tokenization, that we don't have separate tokenizers for different languages. So I think the other paper we had read a little bit on the new DeepSeek paper, and we were talking about anagrams. And there was some interesting write-ups on particularly the anagram mechanism that DeepSeek had created.
So that was a very, very interesting paper as well. So they were trying to incorporate memory into it, but not in memory in the true sense that, the capital of France is, Paris. Anagrams are a bunch of words that commonly occur, right? That's the shape of it, like capital of kind of a thing, right? So what they were doing is they are creating not lookup dictionary, but lookup anagrams that created certain signals for the LLM. So when you start off saying capital of this, it biases the attention network to look into a group of places where it is capital, kind of a thing, right? So it's able to compute faster,
Yeah.
the probability collapses much faster
Well,
than you
and
get some.
it's kind of an
Yeah.
old school, both linguistic and cryptographic tool, right? Where you're looking for the pattern in the language. You're looking
Correct,
at what pairs are most statistically related to each other, or what phrases are most statistically related to each other. So now you know, okay, and because I think about it more from a crypto than a cryptography than a linguistic perspective.
Yeah.
And it's okay if I know that this letter appears frequently and this message is most likely in English, it might be the letter A.
Correct.
Because that is, or letter E or whatever, based on that probability. And that gives me the ability to start to work backwards to figure out what other pieces of the algorithm may be. That works on fairly simplistic cryptography algorithms. By the time you get to modern ones, it's a different story.
Yeah, I mean, I don't know if they borrowed from the same concept or not, but it kind of makes sense because you are not storing the answers to some prompts, right? But you are kind of nudging the model along, look in there, kind of a thing. So it's not the search space for the next token becomes more defined, right? So it doesn't have to go through multiple iteration to come up to the right answer. So again, it comes down to the probability shaping. You're pushing the distribution in certain regions where it has a high probability of picking the right answer.
And if I remember right too, they have to have a little bit of a gateway to go look at it, because you don't want it to always go to that table, because that may not always be right. Because I may not always, when I'm talking about New York, I may not always be talking about New York City. Maybe I'm talking about Rochester, New York. Which is a city in New York, but it's not the same as New York City.
Correct. So if we didn't have the gate, when it fails to do that, the n-gram, and they route it through the entire network to come up with the whole structure, that was very clever as well. So it doesn't always differ to be parrot kind of a thing. You repeat back what you just said, kind of a thing, right? So but yeah, that was an interesting architecture choice where you are incorporating memory into it by shaping the distribution.
So kind of extending what we were talking about with the distillation, we're talking particularly about programming language. Do you think someone's going to build a specific tokenizer for a specific programming language, or maybe an n-gram table for a specific programming language to help with that accuracy?
Probably. I was surprised when I was reading that there was not a tokenization. I didn't even realize that they were not using a particular tokenization for some of the language models, right? So what if we are dealing with a language which has no similarity with English, right? Maybe an assembly or something low level, right? It doesn't look anything like that. That's where you are limiting the LLM's capability, because it's trying to find statistical structure in English mapped to a language which it doesn't have, right? How would that work? So there is probably a need for that, but again, it's where would we put our resources? It's probably more profitable to do it on English, and most of the coding languages are human readable, so they have a lot of similarities with the languages.
Well, the whole reason for programming languages, right? And this gets to an interesting conundrum that I think I'm seeing people already try and do, which is, computers are essentially programmed in binary, or if you're in quantum physics, they're, if you're using a quantum computer now, it's more complicated because now you're using qubits, right? Those have multiple states. Back to probability. But if you're using a conventional computer, it's binary. So instead of everyone wanting to have to write zeros and ones, they started writing assembly, which is hex code basically for those machines. And then because that's a little easier for a human to go figure out how to write. And then they started writing programming languages to make it so it's human readable. And now I'm seeing for some of the large language models and that, where people are talking about large language specific or other more constructed languages to go work with those different tools. It's like, okay, it's full circle to where we started.
I mean, once you get down the path, if you think, you talked about this, like, can LLMs be used for forecasting and things like that, where there's a lot of time series, there's no English involved, there's a bunch of number, right? If there's if there's some effort put in there, that side of things, maybe it will expand its capability beyond the semantic structure of English language or any language, for say.
Well, and IBM actually does have a pretty nice series of models focused on time series. But that's a good point, right? Because most large language models have a problem that they don't understand order or sense of time.
Correct. Yeah.
And that's kind of the way they work, right? Because they're predicting what's going to be next. They don't really think of order of operations.
Yeah, I mean, the IBM thing, they were selecting models to do the time series. But if you even go down, even if you throw a bunch of numbers, ask it to do something, it will try to predict it. And got me thinking, where did they're getting the data from? It's probably some appendix where they have tables and they kind of understand that. But if you're truly dealing with high frequency signal coming out of a sensor, they don't have that recorded or into LLM, because it's so much just numbers, right? So there's probably a opportunity there to look into it, investigate. It's probably a research question rather than off the shelf kind of a product at this point. So yeah.
So we were talking about kind of those constructed programming languages, but one of the challenges with large language models, it's the whole idea of the prompt and the size of the prompt and the context, right?
Yes.
So we were talking about that new RLM paper from MIT. We'll give everyone a full warning. It's dense. That was the first thing Saurabh and I said to each other after we read it. So if we don't get everything that was in the paper, we'll apologize now, and we'll share the paper, and you can go read it on your own. It's complicated, but it's a really interesting idea.
Yeah. So I think they took a completely different path around how do you manage the context, right? Yep. So their principal premise.
So let's talk about what context is first, and how it's usually managed today, and why their approach is different.
So every model have a max context length, which is the maximum amount of body of text or tokens, right? You can hold in while processing, and it could be input. It's generally, when you are recursively generating, it's also output concatenated to that. So it is a limit to it, right?
So let's talk about, you could go, a lot of these are 120 some thousand, there's 64,000 tokens. They're 250. That's enough to put hundreds of pages of text into the model. And so what happens is you put your initial prompt in, and then as you're doing future continued requests, what it's doing is what Saurabh said, is concatenating your previous output to that next question that you put in, so it kind of knows all of that.
Yeah.
Now, one of the things that's already been observed is that if I have a 256,000 token context window, it still only pays attention to certain parts of it.
Right.
You lose some of that.
Yeah.
So what some people have tried to do to help with that is this idea of compaction, where you're compressing and only keeping the key details. But if anybody's ever run something through a whole bunch of cycles of compression, like let's take an image, you take it at full resolution, you keep compressing it to a JPEG, eventually it starts to get distorted, which is what happens with the context.
Correct. And the distortion is not even uniform, because because it's paying attention to certain parts and think that's relevant, and forgetting certain details. So for example, you have instruction for the LLM right up at the top to behave certain way, that can get eroded away very, very quickly, right? So that's the limitation of current models, where the contextless, it's kind of limited that way, and it's by design. You can't just have an infinite amount of memory and compute and all that stuff.
Right now, anybody's trying to buy DDR4 or DDR5 RAM nodes, you can't even buy what you're looking for.
Right. So memory is a bottleneck right now. So with the MIT paper, what they did is they called the input prompt, is keeping it outside. And they are treating the entire knowledge base or the context as a separable entity, right? So the LLMs would write their own code in real time and query that. So it's different from RAG. RAG, the pipeline is kind of fixed. You push in an input, you find similarity, you get something. But it doesn't do, if the LLM decide to run a regex, regular expression code on it to find certain tokens or certain symbols, it can do that. But with RAG, it can't, right? So the paper said that they allowed the LLM to run, and it was able to do up to 10 million tokens, which is massive. Nothing even close to came that, to that range. And it's because it is treating the entire body, or the corpus is searching outside, and it's just querying, and it's getting the results, and it's that the pipeline to query, it's malleable, so the LLM can write its own code to run it and get stuff. So it's not hard coded that detail, which I found was ingenious way to do it. So they are of getting an LLM coding agent, all of that combined, packed together, right? So which kind of begs the question, is it going to be slow? Yes, probably it's going to be slower than any traditional LLM or even RAG, because it's writing, probably there's a mistake, the query didn't fetch good results, it's going to reiterate and come back with it. But if you think about it, I mean, the way you think of this as you have a programmer without no memory. You
Yep.
go look it up in a library, search however you like, kind of a thing, and then it goes and does stuff, right? So it was a really interesting paper for sure.
Well, and I think what they said too, if I remember right in the paper, was there are some use cases where just going straight to a model makes a lot more sense. But
Yes.
when you're looking at accuracy or very complex queries, that's where this approach can provide you both a speed and a cost benefit.
Right.
Now, not always, which is interesting. So I think this is what we're going to have to do some experimentation
Yeah.
with.
Yeah, I think what I read was like, if you're asking a strategic question, what are my operational risks? Maybe, for example, a RAG would pick up the word operational risk and try to grab stuff which is similar to that from your, whatever corpus you're throwing at. Versus this, it may go differently. It can probably find out what are operational, define that, what are my operation fundamentals. It can go anyway. That's the beauty of it. You're not hard coding it from the pre-built phase. It's in real time, it's figuring it out what to do with it. So when it extracts stuff out, it is actually it's devising a theory based on your question and collecting evidence and then coming up with an answer. And since it's not constrained by the RAG framework or anything like that, it's supposed to be more robust and less hallucination. But again, it's early stage, so we'll find out.
Yeah. And we've seen a couple frameworks start to come out with this already built in. I think the paper came out like December 30th or something. So it's a fairly new paper.
Right.
But there are already some groups that are going to implement it. So as we get some more time to test it, we'll let everyone know. Could be for an interesting demo.
Yeah.
So cool. So any closing thoughts?
No, one of the central thing I saw across all of these things is, the movement is what I see. The signal is towards the shaping of the probability distribution. The earlier couple of months back, it was all about context engineering, context, management, and all of that good stuff. The push is now towards shaping the distribution itself. If you control that, you retain a lot of the reasoning and all of that stuff in there, while you are trying to eliminate the hallucination. Because if you're shaping it well, the hallucination probably is the tails, you're chopping them up, and it's not taking from there to hallucinate.
Well, and I think the right term is reduce the hallucination.
Right. Yes,
it's
probably
a
you cannot.
probabilistic tool. You can never completely eliminate it.
There's always that little 0.001% chance at the tail to get that up, right? So that's what the theme I kind of found is like, it's going towards the shaping of the distribution and how it's picking, and it's a good trend for sure. So
cool. Anything you're excited about with stuff you've seen in the last couple of weeks that you think is coming with the AI tech?
The CES had interesting demos with holograms and and stuff like that. That caught my eye. It's like we've seen holograms happen quite in the past, but they were very structured and like pre-recorded right. But with the stuff that you showed today, and the hologram displays available, you could really animate something novel and real time happen.
I've got some projects that I haven't actually dug into yet that I've got on GitHub that you and I will have to talk about.
Yes.
But remember what we were talking about, that we had access to that one corpus of interviews, and you had done an early thing with, I think it was Archimedes or something. It was a Greek philosopher, and we had a brief talking head, and that had to have been 2020 with like BERT before most of the stuff is out there.
Yeah.
We may have to revisit that one. No, I think there's a lot of exciting stuff coming. As Saurabh said, there's a lot more coming with video, and there's a lot of real-time stuff coming out too. NVIDIA's released a couple of things that we'll have to play with that are more real-time text-to-speech and speech-to-text, so you can start to get some conversational stuff going. So very, very cool stuff happening. Thank you for joining us on the Veritas Automata Deep Dive. I'm Ben Savage, the CEO and founder. This is Dr. Sarkar. We thank you for joining us. Please like, subscribe, drop some questions in so we can see what content you're interested in. Otherwise, you'll be subjected to more of my vibe coding failures and horrible video demos. So thanks all.